Good morning, ladies and gentlemen. We're going to do 13.2a today. We're going to actually start doing some fun trig. I love trig. It's one of my favorite things to teach. We're going to talk about angles in standard position and radians today. And then we're going to talk about coterminal angles and then converting between two different types of measurement for an angle. All right. So as we get started, I'm going to draw us our little quadrant system, and I'm going to review a couple of things because we will use these words a lot. So this is in our Cartesian coordinate system. That's a weird word. This is the first quadrant, and the quadrants rotate across the top counterclockwise. So then this would be quadrant 2, this is going to be quadrant 3, and this is going to be quadrant 4. Okay? And then I'm going to talk about the degrees. So, and remember, degrees are a way of measuring angles. So this is going to be 0 degrees. Up here at the top is 90 degrees. Over here on this side, this is 180 degrees. Due south is going to be 270 degrees. And then all the way back around is 360 degrees. Okay, so you will have to know that. Remember that each quadrant is in chunks of 90 degrees. So I have 0, rotating to the left, 90, 180, 270, 360. Okay? All right, just a couple of geometry refresher words. An angle is formed by two rays. Okay? The initial side, all right, is always going to be, for these applications, on the positive x-axis. Okay, so let me get a different colored pen. I'll use orange. This is always going to be the initial side of an angle, and notice that the vertex is also at the origin. Okay, so this is going to be the initial side. Okay, and then somewhere in our quadrant system is going to be the other ray of the angle. So that would be what's considered the terminal side. Okay, so that would be the second ray of the angle. And I like to say it's where the angle stops. Okay, all right. So we call an angle in standard position. Sorry, I was having a hard time spelling standard. Standard position is like our orange angle that we have up above. The initial side is always on the positive x-axis. The vertex, I'll make that dot a little bit bigger. This is the vertex. Okay, and then this would be our terminal side over here. All right, so that's what's called an angle in standard position. Alrighty. Now let's talk about angles rotating. So let me get a different color pen. Okay. Angles start on the positive x-axis always. That's our initial side. And I can rotate what I call across the top. That would be a positive rotation. Or, I'll bring in another color. Just get all kinds of colors today. Rainbow math. I can rotate across the bottom, and that's going to be a negative rotation. So let me see if I can make that a little bit bigger so you can see it. Okay. So a positive rotation is going to go across the top, okay, and that is a counterclockwise. So I'm going to say a positive, oops, you can't see it if I'm writing. I'll scoot it back up in just a sec. The positive rotation is going to go across the top, and it's going to rotate in the counterclockwise direction. The negative rotation, starting at the x-axis, the initial side, we always start here at x is equal to 0, is going to rotate across the bottom, and that's going to be a negative rotation. So in our trig, a positive rotation, for an angle is always going to be counterclockwise, okay, and that's the way that we show it, and I'm going to write the word counterclockwise. Okay, and then I'm using colors so you can kind of reference it from our diagram. The negative rotation for an angle is going to be in the clockwise, and that's going to be negative. So there are a few things that you're just going to have to memorize in this chapter, and this concept is one of them. So I say across the top is positive, across the bottom is negative, okay? And if I have a negative angle, so I'm going to write a negative theta, that does not mean that the value of the angle is less than 0. It just talks about the direction of the rotation. So negative is going to talk about the direction, and I'm going to abbreviate direction as DRXN, the direction of the rotation. Same thing with positive. A positive angle tells you the direction of the rotation. Okay, because we can rotate both directions. So thinking about if I screw a cap on and tighten it, or I unscrew a cap, one would be a positive rotation, one would be a negative rotation. All right, so let's do some examples. Our first example, I know pink's kind of hard to see, is going to say draw the angle in standard position. Whoops, I ran my words together. In standard position and label. The labeling is going to be hugely important in this chapter because oftentimes the labeling is going to count as your work. So I'm going to do several of these. So the first angle is 240 degrees. You always, did I mention? Always start with a little coordinate system. This is what I'm going to expect to see on your papers. I always start at 0 because this is the standard position. Remember, that's my initial side. And I'm going to go 240 degrees. So I go 90, 180, and 180 plus 60. So my angle is going to end up in the third quadrant. Okay, this is the initial side. This is the terminal side. I have to show the angle of rotation. I label what's called the reference angle. So I'm going to draw a little arrow right here. This is called the reference angle. And it's always going to sit, always, one of those very few times that we use the word always in math, but this is one of those times. It always sits on the x-axis. Okay? And then I'm going to put my 240 degrees out here, showing that that terminal side has a measure of 240 degrees. So if you have to draw an angle in standard position, these are my expectations. And then we will do additional math on them later. You could also label this angle right here. These two angles are complementary, meaning that they sum to be 90. So that little guy is 30. The only problem with labeling this one is you're tempted to do math. We will always do math only on the reference angle, and the reference angle always sits on the x-axis. All right, our second example is going to be 500 degrees. Well, if you'll remember from geometry, if I start with my little diagram, okay, all the way around is 360 degrees. So that means I'm going to go 360 plus some. So if I do 500 minus 360 degrees, that's one full rotation, I'm going to get 140 degrees. So that helps me draw my angle. So now let's go through the process. So I start at x is equal to 0, okay? So 0 degrees, I'm going to go all the way around. There's 360, and then I'm going to go 90 plus 50, and that's going to give me 360 plus 40. So I'll talk you through it again. I'm starting here at 0. I'm going to go all the way around. There's 360. There's 90 plus 50. So this little guy up here is 50. The reference angle is 40. Okay, the reference angle is the important one. So I'm going to circle that one because that one's important. That's 40 degrees. Up here on the top, I would label my 500 degrees. Notice that I'm including my units on my angles. I get cranky when you don't. And then that one's done. The 40-degree angle is very important. The 50 is helpful for getting to where we need to be. but we will always do math on the 40. All right, I have one more example like this. Okay, so this one's going to be a negative 50 degrees. So again, I always start with my little coordinate system. Notice I always put 2 arrows on it. Sorry, I had to have a coffee break. Now I'm going to rotate in the negative direction, which means I'm going to go across the bottom. Okay, 50 degrees is going to be in the 4th quadrant, so I'm going to rotate this direction. This is 50 degrees. The arrow of rotation manages the negative, and then down here I'm going to put a negative 50 degrees. This 50, because it's sitting on the x-axis, is my reference angle. All right, so the next concept that we have to talk about in this particular section are coterminal angles. Coterminal, cool word, actually fairly easy concept. All right, so we're going to talk about coterminal angles. So basically what it means, and I'll draw us an example, a coterminal angle says that there are 2 different ways to get to the same angle. So I could get to this angle, so my initial side's here, okay, there's my initial side always. I could get to this terminal side by going this direction, or I could get to this terminal side by going in the opposite rotation. And hopefully you can see the difference. This guy's pink, this guy's orange. Maybe those 2 colors are too close. I'll make this guy green. There we go. How's that? All right, so a coterminal angle, this one would be positive, this one would be negative. Both angles will get me to the same terminal side. Alrighty, and oftentimes we'll talk about find a positive and negative coterminal angle. So let me do a little example. So you're going to be given a 60-degree angle. We'll draw it in standard position, and it wants you to find a positive and a negative coterminal angle. Okay, so I'm going to draw my angle in standard position because that should always be your first step. All right, so if I draw 60 degrees is in the 1st quadrant, and it has a positive rotation. This little angle is 60, there's my reference, and then I'm going to put it out here on the outside edge. Okay, so let's do the negative rotation first. So for my negative rotation, I'm going to start at x is equal to 0, and I'm going to go all the way around to get to the angle going the opposite direction. Well, if I do that, it is, if I had gone all the way to 360, all the way to here, and I backed up 60, so I take away 60, it's going to be, and I put the negative rotation, back up positive, so it's going to be a negative 300 degrees, okay? So that's going to be my negative coterminal. So let me talk to you through that again. I'm going from the x-axis in the negative rotation, and I'm going to go all the way around to the x-axis to a negative 360. I'm going to go positive 60, and then I get the negative 300, okay? So now let me walk you through the positive coterminal. The original angle is already positive, so the only thing that I could do is take a lap. And I'm going to draw it out here, so I'm going to start at x is equal to 0. I'm going to go all the way around, woo, took a lap, and then go back to the 60, because I have to end up in the same location, on the same terminal side. So that's 360 in the positive direction, and I went another 60 degrees, so that's going to be a positive 420 degrees. Okay, so if I write my answers, my negative coterminal, notice I am identifying my answers, is a negative 300 degrees, and the positive coterminal is going to equal 420 degrees. Okay? All right, so let me do a couple examples of coterminal angles. Okay? The directions are going to be very similar. It's going to say find a positive and negative coterminal angle. Negative coterminal angle. Okay? All right, so our first one is going to be 395 degrees. So let's talk through this a bit. All the way around is 360. So if I do 395 minus 360, I'm going to get 35 degrees more. So let me draw our angle in standard position. Okay? So the original angle, 395, is all the way around plus 35 degrees more. Okay? Notice my little arrowhead showing the direction of rotation. This angle, the reference angle, is 35 degrees, and this is my 395 degrees. So lucky for us, I'll do it in different colors, the positive coterminal is right there. So I'm going to write that my positive coterminal is going to be 35 degrees. So that was actually kind of easy. So my negative coterminal is going to go the opposite direction, starting at x is equal to 0, and I'm going to go that way so that I end up at the same terminal side. And I'll do my little math over here. So if I went all the way around a negative 360 and then went back that 35 degree angle, I would get a negative 325. So my negative coterminal is going to be equal to a negative 325 degrees. Alrighty? So one more example of these. This time you're going to be given the angle 230 degrees. Okay? So I'm going to start by drawing my angle in standard position. There's my little quadrant system. 230 is going to be 90, 180, plus 50 degrees more. Okay? So I went 90, 180, plus 50. So I'm going to label that little guy. That's my reference angle. Okay? So this one is the 230 degrees. So let's do the negative coterminal first. So if this angle is 50, this angle is 40, right? Because they're complementary angles, they add up to 90. So my negative coterminal is going to be a negative 90 and a negative 40. So my negative coterminal is going to be a negative 130 degrees. Now the positive one's a little bit weird because I've already gone over to 230, so the next thing that I can do is take a lap. And so I'll start at 0. We always start at 0. I'm going to take a lap, and I'm going to go all the way around. So my positive coterminal, oops, spelled it wrong, I-N-A-L, is going to equal my 360 positive plus all the way back to 230. So that's going to end up being 590 degrees. Okay? So those are my coterminal angles. All right. So the next thing that we need to talk about are units of measure for angles. So that kind of section is done. All right. I'm going to draw my little coordinate system so I think it helps to see it. In degrees, which is how we're used to measuring angles, this is 0, this is 90 degrees, 180 degrees, 270 degrees, and then all the way back around is 360 degrees, because a full circle is 360. But when we use trig, there's another unit of measure that we use for angles called radians. And radians are significantly bigger, so I'm going to write much larger than a degree. So if we're doing something maybe in very large applications, in science, in the solar system, in navigation, or whatever, we might use radians. So 1 radian is going to equal 57.30 degrees, which is kind of weird. Or I could say 1 degree is equal to 0.017 radians. Well, those numbers are pretty weird. So we're going to do a conversion for our radians a little bit differently. So let me draw a new coordinate system. Okay. So this is 0 radians. So this one's going to be in radians, by the way. Okay, so this particular set of angles is in radians. This is still 0 radians. Now this is pi over 2 radians. This is pi radians. This is 3 pi over 2 radians, and all the way around the circle is 2, oops, you can't see that, 2 pi radians. Okay? you are going to have to memorize these 4 angles, technically 5. So 0, pi over 2, pi, and 3 pi over 2. So the conversion factor that we're going to use when we are converting from angles to degrees, from degrees to radians or from radians back to degrees, is going to be pi radians is equal to 180 degrees. This is the conversion factor that we're going to use. So oftentimes when people teach you how to convert angles, they teach you in some situations you multiply, in some situations you divide, and I have found that it's hard to remember when to do what. So I'm going to show you how to do it with dimensional analysis, okay? And you use dimensional analysis in your science classes a lot. It's actually very simple. A-L-Y, sorry, I can't spell, okay? I'll write my conversion factor up here so I know that there are pi radians in 180 degrees, okay? So the whole goal of dimensional analysis, so if I wanted to convert feet to inches, so if I had 13 feet and I want to convert it to inches, this is how I do dimensional analysis. I do it with a little table. I don't care how you do it, but this is how I do it. So I would put what I'm starting with up here. In dimensional analysis, I have to get this unit to cancel, so instead of remembering when do I multiply and divide, I would just put that there are 12 inches in 1 foot, okay? Notice that instead of remembering which way the conversion goes, do I multiply or divide, all I have to be concerned about is that that cancels and that the unit that I want ends up on the top. And that's kind of all there is to dimensional analysis. So I multiply all of the numbers that are on the top and then divide by all of the numbers that are on the bottom. So if I finish this conversion, it would be 13 times 12, which would be 156 inches. Okay? So it's actually fairly simple. So now let's do some conversions. So let's do angle conversions. And I want to convert to the opposite measures. So if it's in degrees, I want to convert to radians, and if it's in radians, I want to convert to degrees. Okay, so our first problem, I want to have 125 degrees, and I want to convert it to radians, okay? So I will do all of my problems exactly the same way, because I don't like to remember anything that I don't have to. So I'm going to write 125 degrees. I'm going to draw my little table, and I know that there are 180 degrees. Notice I put it on the bottom because I need the degrees to cancel in pi radians. The degrees cancel, and so now I'm left with 125 pi over 180 radians. Now a couple of things that are standard when we're doing radians. Almost always we're going to leave this as a reduced fraction and we're going to leave pi as part of the answer. So what I'm going to do in my handy dandy grapher, I'm going to do 125 divided by 180, and I'm going to hit enter, and then I'm going to math frac it, and I'm going to get 25 pi over 36 radians. And that is the appropriate answer. So when you're converting from degrees to radians, you always want to leave it as an angle with a pi and as a reduced fraction. And because reducing the fraction is not the primary focus of the problem, I'm okay if you math frac it in your calculator, which is what I always do because I tend to be a wee bit lazy. All right, the next one is I'm going to convert 140 degrees, and again, sorry, I got the hiccups. I want to convert it to radians. So I start with my little table. I have 140 degrees. I usually write the word degrees because sometimes that little degree symbol gets lost. I know that there are 180 degrees in pi radians. So that's going to be 140 pi divided by 180. Sorry, my brain and my mouth aren't working. My degrees cancel, okay? If I math frac that, I know right off the bat that the zeros go away. If I reduce it, I end up with 7 pi over 9 radians, okay? And I usually just abbreviate radians as RAD. My next example then is going to go the opposite direction. So now I'm going to have a negative pi over 12 radians, and I want to go to degrees. Okay, so I'm going to start the same way, but because radians starts off as a fraction, here's the negative pi. I'm going to put my radians up there, and I'm going to put the 12 in the denominator. I know that there are pi radians in 180 degrees. So now notice that the pi's cancel, the radians cancel, and I'm left with a negative 180 divided by 12, and I'm going to get a negative 15 degrees. Okay? So if you do your conversions this way, and I don't care how you do it, if you want to do it a different way, whatever, but this is the way I have found students are the most successful. My next one, I'm going to have 5 pi over 4 radians. I want to convert it to degrees. So again, I'm going to do my handy dandy little table. Okay, so I have 5 pi radians over 4. There are pi radians in 180 degrees. Pi radians cancel. So now I have 5 times 180 divided by 4, and I end up with 225 degrees. So it's really not a difficult concept. Okay. All right, so now let me give you your problems. This really is one of my absolute favorite chapters of math. This one and logarithms I think are probably my 2 favorites. All right, so now your first problems say draw the angle in standard position. Labeling well. Okay, and you can go back and look at the video if you need to know how to label, or look at your notes, because in theory you're taking good notes from the video. Then find a positive and negative coterminal angle. Okay, so the first one, sorry, I'll use a 1, is 65 degrees. The second one is 230 degrees, and the third one is a negative 300 degrees. So draw those in standard position, then find the positive and negative coterminal angles. Your second set of problems says convert the degree measure to radians. I'm just going to write to the other, and I know that's a little bit vague, measure. So if you're given an angle in degrees, you're going to convert it to radians, and if you're given an angle in radians, you're going to convert it to degrees. All right, so number 4 is going to be 135 degrees. You're going to convert that to radians. Number 5, a negative 50 degrees. Number 6, 5, ooh, we already did that one, my bad. Let me erase that. Let's do 7 pi over 3. Almost did your homework for you. 7 pi over 3. And then the last one that I want you to convert is pi over 10. Alrighty, good luck with your math. This is an exciting chapter, and I will see you tomorrow.